Okay, so now we're getting into the very interesting topic of multiple cluster in Kafka. And this is an overview, this is not a hands-on. I'm giving you pointers, it's kind of a brain dump. So just to set the expectations right. Kafka can only operate well within a single region. And by region, I mean geographical region. Okay? So if you have a Kafka cluster in America, it will not work well if you're in Asia, and vice versa. Therefore, it's super important that if an enterprise is global, it usually has Kafka clusters all across the world, and the clusters replicate data between them. So here is a beautiful map of the world, and if I'm a huge company and I have Kafka clusters, I'm going to have them everywhere. Maybe I'm going to have a huge one in America because that's where my business is. Maybe a large one in South America, maybe a decent one in Europe, in Asia, and a small one in Oceania, okay? And my applications, basically, they revolve around the clusters that they're assigned to. So I'll have my applications in North America, I'll have some applications in South America, and so on, okay? The applications revolve around their local cluster. They don't interact with other clusters. But what if you need data from a cluster in Europe while you are in Asia or whatever, right? Well, you need replication. So replication basically is an exchange of data between clusters, set up very specifically, so that the clusters can share data massively with a high throughput in between regions. And so the replication can happen in any way, any order. For example, on this diagram, we see that North America is exchanging two ways the data with South America, while South America is sending one way the data to Europe. So is the same for Oceania and Asia. So it just gives you an idea that you're pretty free around the replication mechanism you want, but this is a usual setup when you have a global organization. So now a replication application, it's super easy to think about it. It's just a consumer from a cluster and a producer to another cluster. And there are different tools to perform it. And the first one you may have heard of is Mirror Maker. And Mirror Maker is the open source tool that ships with Apache Kafka. The thing is with Mirror Maker is that while it does its job okay, usually when you have huge scale, and again, huge is different for everyone, but when you have huge scale, it may prove itself to be a bit tricky. So Netflix, for example, they use Flink and they wrote their own application. Unfortunately, it's not open source, otherwise I would give you a link. Uber developed something called uReplicator, and they have a blog post about it, and they address performance and operations issue with Mirror Maker. And actually, uReplicator is open source, so if you have a global organization, this may be something that you want to look into. Comcast, they've developed their own open source Kafka Connect source connector, which I think is quite nice and does its job well. I don't know if it has been tested extensively, but if Comcast works with it, I'm pretty sure it's good. Then Confluent, they have their own Kafka Connect source as well, but this one is paid, it's enterprise license supported, so I think it's really, really strong, but you do have to pay a lot of money unless you have a license with Confluent. Overall, there's lots of options. There's not one way of doing things in the Kafka world, unfortunately. So try these one by one and see the one that works for you, for your use case, before you go ahead and try to write your own, okay? So for a cluster replication, there are basically two designs that you can do. Number one is active-passive. And active-passive is when a producer will write to one Kafka cluster, and the second Kafka cluster will just replicate from the first one, but it will not receive a producer on that topic. So the right-hand side Kafka cluster is called passive, while the left-hand side is called active, because the active receives the writes from the producer. And here, the consumers consume from both clusters that they're local to, okay? And that's the important part. So with this setup, we basically enable the consumers in the second region to get the data from the producer in the first region. Alternatively, you get active-active type of setups. And so this is when producers produce to the same topic in both clusters, and the clusters are smart enough, the Mirror Maker is smart enough to just replicate the data between these two topics, and so that there's a crossover. Usually when you have active-active type of setup, the topics have a suffix of the cluster they came from. This way there's no overlap and no infinite loop. And again, the consumers consume the data globally, but from the local cluster. So this is the two different cluster for replication. So the first one I would say is when you have an aggregate cluster for doing analytics, and so you pipe all the data from all your other clusters around the world into this one Kafka cluster, and maybe this one will go straight into Hadoop. Well, active-active is when you have a global application that needs all the data globally in each local region. So you would have something like this, active-active. Overall, this is a very complex topic, far beyond the beginner's level, okay? But I want to give you pointers for you to figure out how to make it work for yourself. So active-active is, as I said, you have a global application, a global data set, and active-passive. You have an aggregation cluster, and you want to create some form of disaster recovery strategy. But let me tell you something, it's really hard. And a cloud migration if you migrate from on-premise to cloud cluster, for example. Finally, something that is a huge gotcha from real-world insights. When you replicate, it does not preserve offsets, just the data. So offset number 8 in your cluster in Asia is not equal to offset number 8 in your cluster in America. It just is not true. And so that's a big gotcha when you do replication. And this is why disaster recovery strategy is so hard to do.